Okay, this is the Herminator here with another exciting graphing thing. Now this is all stuff you've already done, but this time it's kind of all thrown together. So look at this first equation, and it says, so there's different techniques to graphing depending on how the equation's set up. It depends on what formation it's in. So what we have is y equals negative 2 times x plus 3. Now I have a simple question. Here's my equals. Is the y out front of the equation by itself? Yes, it is. So if y is by itself, there's actually two methods. So what we're going to do first is put 3 inputs for x. Okay. Now if I don't have a fraction, I'm just going to pick 0, 1, and 2 and insert that in for x. Okay. So negative 2 times 0 plus 3 gives me 3. Now let's put 1 in for x, so negative 2 times 1 plus 3 gives me 1. Now let's put 2 in for x. So negative 2 times 2 plus 3, and that gives me negative 1. Okay, so I graph the points 0, 3. Remember, if x is 0, don't move sideways at all. You just go up to 3, and that's my 0, 3 point. 1, 1, so I go 1, up 1, so 1, 1. 2, negative 1, I go 2, down 1, so 2, negative 1. And then we make our points, our line through those points. Now, another way you can do it if y is by itself is to use slope and y-intercept. Okay, so slope is m and the y-intercept's b. So that's m and that's b. So the b is my y-intercept, so that's 3. So on the y-line, I'd go make a point at 3. And then the slope is negative 2. But since I need the slope to be a ratio, it's negative 2 over 1. So I go down 2 and right 1. So from this 3, I go down 2, right 1, down 2, right 1, and I essentially get the same line, okay? Either do this or this. It doesn't matter which. When you're doing the problems on your own, just do whatever one you like better. If you like the 3 inputs for x, go with that. Or if you like the slope y-intercept, put it in for that. Okay, my next one. Is the y in front by itself? Yeah, looks like it to me. So we can do the 3 inputs for x. Now we have a fraction here with a 4 in the denominator, so I'd want to pick multiples of 4 so that the fraction cancels. Okay? And then I just input. So 3/4 times 0 minus 1 gives me negative 1. 3/4 times 4 minus 1 gives me 2. And then we insert 8. 3/4 and then 8 minus 1 gives me 5. Okay, so 0, negative 1. Don't move sideways at all. Go down 1. Okay. 4, 2. I go 1, 2, 3, 4, up 1, 2. So that's 4 and 2. 8, 5. I go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. And that's 8, 5. Okay, so there's a line. Okay, another way I could have done it is the slope and y-intercept method. That's m, that's b, so my y-intercept's negative 1. So there would be a negative 1 point. Then my slope is 3/4, so I go up 3 and right 4. So 1, 2, 3, 1, 2, 3, 4, there's a point. 1, 2, 3, 1, 2, 3, 4, there's a point. It would be the same thing. Okay, next problem. Is the y by itself in front? Yes, okay. So again, we can do the 3 inputs for x. There's no fraction here, so I'd go 0, 1, 2. So 2 times 0 minus 4 gives me negative 4. 2 times 1 minus 4, that gives me negative 2. Then 2 times 2 minus 4 is going to be 0. Okay? All right, so 0, negative 4. So on the x-axis, the one going sideways, we don't go sideways at all. We go down 4. 1, 2, 3, 4. 1, negative 2. So I go right 1, down 2. And then 2, 0. Right 2, right there. Okay? Points line up perfectly. And there's my line. Again, another way you can do it is y equals mx plus b. So slope, y-intercept. The y-intercept's the negative 4, and the slope is 2 with a 1 under it. So negative 4 is my y-intercept. Then I go up 2 and right 1. Up 2, right 1, and we got our line. Okay, my next problem. Y is again by itself, so I want to do the 3 inputs for x. But this time we have a fraction with a 3 in the denominator, so I pick multiples of 3. Okay. So negative 1/3 times 0 plus 6 gives me 6. Negative 1/3 times 3 plus 6 gives me 5. I don't know about you, but I'm guessing the next one's 4. So 0, 6. Remember, that first point's always up and down. So 1, 2, 3, 4, 5, 6. 3, 5. So 1, 2, 3, 1, 2, 3, 4, 5. Okay. Okay, and then 6, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay, so those are my points. Line goes right through them. Okay, and again, another method, if the y is by itself, we can do the m and b. So the y-intercept's 6. So I'd go make a point at 6. And then negative 1/3 is the slope. So I go down 1, right 3. Down 1, right 3, there'd be a point. Down 1, right 3, there'd be a point. And it's the same line. Okay, now as I move on, 4x plus 8y equals 16. Is the y by itself? No, it's not. It's not even close. I got more than just y in front. So the way the only way pretty much to do it when y is not by itself is to have 2 points on this table where we have 0 for x and 0 for y. And then I copy down that equation twice. And then I go from there. Now if x is 0, to find the y, we get rid of 4x, because 4 times 0 is 0. So 8 times y equals 16. So I divide by 8, and that's going to be 2. So that's on the y line, 0, 2. Okay, now if y is 0, we get rid of 8y and the plus. So 4 times x equals 16, so I divide by 4, and x is 4, so 4, 0. Okay, so I have 1 point on the y and 1 point on the x. Okay, my next problem, 3x minus 4y, and that's a plus negative. Now, is the y by itself? No, it's not even close, so we want to use this, the table where I got the 0 and 0. So 3x plus negative 4y equals negative 9. 3x plus negative 4y equals negative 9. Okay, so if x is 0, Negative 4 times y equals negative 9, so I divide by negative 4, and negative 9 divided by negative 4 is 2.25. You got a decimal, that's okay. So it means on the y line, I just go up 1, 2, and then a little bit past that. Okay, now if y is 0, 4y is out, and then 3 times x equals negative 9. So I divide by 3, and that's going to be negative 3. So I go left 1, 2, 3. And again, that's 0, 2.25, and this is going to be negative 3, 0. Okay, and then I just connect those 2 points. Okay, my next problem, 4x minus y equals 8. So is the y out front by itself? No. Okay, so again, we have to use this method with the 0 in for x, 0 in for y. So put a 1 in front of that, make it plus negative on that one. So 4x plus negative 1y equals 8, and 4x plus negative 1y equals 8. So if x is 0, let's get rid of 4x. So negative 1 times y equals negative 8, so I divide by negative 1. That's negative 8, so 0, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now if y is 0, we get rid of 1y, so 4 times x equals 8. So if I divide by 4, that's 2. So that's 2, 0. Okay, so I go up right there. And that's pretty much the only way you can graph it if the x and y are on the same side. I mean, there's another way, but it's not even worth going over because it takes forever. Okay, then this one. Again, the y is not by itself. So I copy down the equation twice. So if x is 0, we can get rid of 5x because x is 0, so we get rid of that letter and the number in front of it because the number in front of it is just times by 0. So 2 times y equals negative 20, so I'm going to divide by 2, and that gives me negative 10. Now if y is 0, we can go ahead and get rid of that, and then I divide both sides by negative 5, thank you, and that's 4, okay? So 0, negative 10. We got to go by 2s. Anything past 9, you got to go by 2s. So 2, 4, 6, 8, 10. So that's 0, negative 10, and then 4, 0. So 1, 2, 3, 4. Okay, so that's it. Now remember, if y is by itself, we're going to use the 3 inputs for x. Remember to watch out for fractions. If you have a fraction, you pick multiples of the denominator. Or if y is by itself, you can use the MB slope y-intercept. If you have y not by itself, you need to use the 0, 0, where you copy equation twice and cross out. Okay.